Hello everyone, I am going to demonstrate the estimation of zinc using approximately 0.05 molar EDTA solution and zinc sulfate crystals. This experiment falls in Practical 7 of B.Sc final year students of BU, BCU as well as BNU. This is an example for complex symmetric titration and about which all the theory parts you are studying, the students are studying in the theory part, like theory of the paper 7 part. Now, coming to the experimental part of this experiment, there are two parts for this experiment, part A and part B. Part A is preparation of standard zinc sulfate solution and standardization of EDTA. Standardization in the sense finding out the exact molarity of EDTA solution. So, first of all, we have to prepare standard zinc sulfate solution, for which the zinc sulfate crystals would be given by the teachers in a weighing bottle. So, the students are supposed to find out the weight of the zinc sulfate crystals along with the weighing bottle and note down the weight in the observation. Then, transfer the content of the weighing bottle in the funnel which is kept above the 250 ml standard flask, in which we have to make up or we have to prepare the solution. To transfer completely, just tap the bottom of the weighing bottle and then before adding water, just add a few drops of dilute sulfuric acid. This is added to dissolve if any zinc hydroxide precipitate has formed during this reaction. Now, after that, we can add distilled water. In complex symmetric titration, we use only distilled water. Complete funnel, the inside part of the funnel is rinsed with water. The stem of the funnel is also washed with water. Then keep the funnel aside and try to dissolve the crystals in minimum quantity of water. Now it is completely soluble. Now we can make up the solution till the mark. Now it's nearing the mark. When it is very near to the mark, we should use the pipette to add the last few drops of water. Slowly add the water so that lower meniscus of the solution should coincide with the mark on the standard flask exactly like this. So now we have prepared standard solution of zinc sulfate. Shake the solution well for uniform concentration. So the first part of the experiment is over, which is preparation of standard zinc sulfate solution. Now using the solution, we have to find out the exact concentration, exact molarity of this EDTA solution. EDTA solution should be taken in the burette. Now, before filling the burette, we have to rinse the burette with EDTA solution, then fill the burette with EDTA solution. So here I have filled already. We have to fill till 0 mark of the burette. Now, using a pipette, titration should be done. Titration will be between burette and conical flask. In the conical flask, we have to take the prepared zinc sulfate solution, then buffer and the indicator which is bigger from black. So before adding the solution using a pipette, the pipette should be rinsed with the standard solution, which is zinc sulfate solution, which we have prepared just now. Before taking the solution, shake well again. Take little bit of solution just for rinsing, then rotate and let the entire solution touch the inner part of the pipette, especially till the mark and the nearby area, and then discard the solution. Rinsing can be repeated. Then after rinsing, fill the pipette. Again, this should be till the mark exactly. The lower meniscus should coincide with the mark on the pipette exactly. Then hold it tight with your forefinger. Then transfer to the conical flask. Both should be kept in a slanting position while adding the solution from the pipette. A few drops will be struck, so just tap the tip of the pipette with the bottom of the conical flask. So that too will be removed. As I have told earlier, to this we should add buffer. Complex chemical titration will be performed always in presence of a buffer solution. This is ammonium chloride, ammonium hydroxide buffer, and this is taken approximately 5 ml. That is added to the conical flask. Then the indicator, which is areochrome black tea indicator, a pinch of the indicator is added just to get the color. Now we got wine red color. This color is termed as wine red color. While during the titration, the intensity of this color will be more and more. So just add to get light wine red color. Now, keeping a white background, we can start our titration. Before starting, make sure the solution is at 0 only. The end point is the color change from wine red to blue color. So, till we get a blue tinge for the solution, we can run down the solution very fast. Very near to the end point, at the reaction mixture where the EDTA touches, there will be blue color development. So, afterwards we can slow down the reaction. Now the blue color has started forming at the place where EDTA is touching the reaction mixture. Afterwards we can add slowly. Yes. Now it has completely converted to blue color. So this is the end point. This is the advantage of taking a white background where we can make out the blue color exactly. So this is how we have to determine the end point. Take out the burette and hold the burette exactly in the same line of your eye and try to read the burette. This 22.9. Note down the reading in your observation and repeat the titration for concordant value. Same value we should get for, or same value should come twice. That is called end point. It's not any average or anything. Same value, if it is 22.9, it should come twice. That is called end point. You can take more than 3 or 2 or 3 or 4 trials, but two values, same value should come twice. That is called concordant value. From the concordant value, we know how much EDTA is required to react exactly with 25 ml of standard zinc sulfate solution. So from that value, using the calculation steps which is there in your manual, we can calculate the exact concentration of EDTA solution which is provided. That's about the first part of the experiment. Coming to the second part of the experiment, which is estimation of the given zinc sulfate solution. Zinc sulfate and EDTA. In the first part also zinc sulfate and EDTA. That is the prepared zinc sulfate. This is the unknown zinc sulfate. So second part, for the estimation of zinc sulfate, the solution will be given in a 250 ml, another 250 ml standard flask, little bit solution would be given. So this solution is the unknown solution. This we have to make up first. No need of adding any sulfuric acid here, because already for preparing that unknown solution, we have to use sulfuric acid. So here directly we can add water, distilled water to make up. Now it's nearing the mark. So after this we can use pipette for the last 2-3 drops. Now it's exactly till the mark. The line is coinciding with the mark. This is called making up. Stopper the standard flask and shake it very well for uniform concentration again. So this is our unknown solution, unknown zinc sulfate solution. Now from here, just like we have done in the first part, fill up the EDTA, fill up the burette with EDTA till 0 you can fill up. Then take out 25 ml of the solution, unknown solution, to the conical flask. Add 5 ml of buffer solution, a pinch of EDTA, and do the titration exactly in the same way as we have performed in the first part. We'll be getting an endpoint, repeat that for concordant value, and you'll be getting the volume of EDTA required to react with the unknown zinc sulfate solution also. From the titer value, from the concordant value, using the calculation steps in the procedure, we can find out the molarity of the unknown solution as well as amount of zinc present in the given solution. This is how this experiment has to be performed. Myself, Dr. Jisha, and with me, Professor Shubha. We are from Department of Chemistry, the Government First Grade College, Vijayanagar, Bangalore.